In this video, I'm going to go through 10.1. We're going to start with converting degrees to radians and then radians to degrees. So if I'm given an angle in degree measure to convert to radian measure, so to go from degrees to radians, I'm going to multiply by pi over 180 degrees. So if I have 110 degrees, I'm going to multiply that by pi over 180 degrees. It's not 188. And again, the reason that we're doing this is because pi and 180 are actually equivalent. So 180 degrees is pi radians. And so when we're doing this in degrees, what we want to do with our value is write it as a simplified fraction and keep pi involved. So write as simplified fraction. And we want to keep pi in our answer. And so what I'm doing with this is I'm really reducing. And so the reason that I have the 180 degrees in the denominator is that when I'm converting units, I want my units to cancel. So think about that as the units, right? Degrees are a unit of measure. And so what I'm going to do is reduce 110 over 180 since they both end in a 0. Dividing by 10 is reducing out that 0. So what we have left in our numerator for the first expression is just an 11, and the numerator of our second one is pi over our denominator that's left is 18. Since 11 and 18 don't reduce, that means that 110 degrees is equal to 11 pi over 18 radians. If I do the 30 degrees, so we're going to multiply by pi over 180. And then reduce what we can. We will always be able to reduce that degree measure. So that's the clue that we're using the correct form of the ratio to convert. And then this one again ends in a 0, so I can divide by 10. And reduce out the zeros. So I've got 3 pi over 18, but 3 and 18 reduce more. 3 goes into 18 6 times, so this is actually equal to pi over 6 radians. So when I'm converting from degrees to radians, I'm using that ratio pi over 180 degrees. When I want to do the opposite, I'm using the reciprocal of that ratio. So when I'm converting from radians to degrees, I'm going to multiply by 180 degrees over pi. And what's going to happen here is pi should reduce away. And for these ones, instead of keeping pi and writing it as a fraction, we're going to calculate the decimal if necessary. So we're going to multiply by the reciprocal of that conversion factor, 180 degrees over pi, because in this case, we want the pi to reduce away as opposed to the degree units to reduce away. So in example B, we're looking at pi over 7. And so we're multiplying this by 180 degrees over pi. And so the first thing that we do with these, the same way that we reduce out the degree symbol, we're reducing out pi. So that means that we've got 180 degrees over 7. Since 7 does not go into 180 degrees, we're just going to divide that. So if I do 180 divided by 7, that gives me about 25.7 degrees. So pi over 7 radians is equivalent to 25.7 degrees. And then let's do 2 pi over 9, just so we get a little bit of a different perspective there, since that one has a coefficient in the numerator and B doesn't, so B will follow just like A did. We're going to multiply, again, always by 180 degrees over pi for each of these problems. And then our first step should be to reduce away the pi, so pi reduces. And then with this one, we're really finding this value. So the fastest way to get the answer is to divide before you multiply. So if I divide 180 by 9, 9 goes into 180 20 times. And so I can reduce that 9 goes into itself once, and 9 goes into 180 20 times. So what we have left is 2 times 20 degrees, which means that this is equivalent to 40 degrees. Okay, so that's converting between degrees and radians. We're using the same ratio, and it's reciprocal depending on what we're given. So if we're given degrees first, we want the 180 degrees to be in the denominator. If we're given radians first, we want the pi to be in the denominator so that those units or symbols can reduce away in our first step.